This is 11.7, day 2, rationalizing the denominator. So before we talk about that big word, rationalizing the denominator, let's look at some things that are not in simplest form. When all the following are true, then these are in simplest form. If there's no integral radicand and it has a perfect square other than 1. So for example, square root of 20 is not in a simplest form because you can actually do a factor tree on it, and 2 will have a twin, so that means that 2 will come out and 5 will stay in. So that's in simplest form. So square root of 20 is not in simplest form. Okay? If you have a fraction and the denominator is not a perfect square, then that is not in simplest form. And this is what we're going to learn how to do today. Same thing on the next one. If you have a radical in the denominator and that radical is not a perfect square, then we're going to learn how to rationalize and put it in simplest form. So I'm going to show you how to make fractions or radicals that are in the denominator. We're going to show you how to put those in simplest form. Alright, so let's look at the steps first. First step is reduce if needed. Okay, if your fraction needs to be reduced, then reduce first. Then we're going to rationalize. If there's no perfect square in the denominator, that's whenever we rationalize. If there's a perfect square in the denominator, there's no need to rationalize. We just simplify. Then we're going to simplify after we rationalize, and then if needed, we'll reduce again. Okay, so on this first one, 5 is square root of 5 is in the denominator, and 5 is not a perfect square. So we're going to rationalize. In order to rationalize, we multiply by a fraction that is actually equal to 1. But every fraction is going to be different. It's going to depend on what's in the denominator. Well, square root of 5 is in the denominator. So my fraction will be square root of 5 over square root of 5. So that's the rationalizing part. It's multiplying by a fraction that is actually reduced to 1, but we are going to use whatever is in our denominator. Now, I don't want to reduce that. I don't want to reduce that to 1 because that would put me back to my original problem. So what I'm going to do now is multiply the numerators. So that's 3 square root of 5 over, and then next I'm going to multiply the denominators. So square root of 5 times square root of 5 is square root of 25. Now, before I reduce, because I don't want to reduce yet, I'll get back to my original problem, I want to simplify. So 3 square root of 5 won't simplify anymore, but the square root of 25 is 5. So this is my rationalized, simplified answer. Now, some of you may be asking, well, can't we reduce this 5 and this 5? No, because this 5 is underneath the radical. This 5 is not underneath the radical. So they only will reduce each other if they're both underneath the radical or they're both not underneath the radical. Okay? All right, let's look at another one. Square root of 2 over square root of 3. 3 is not a perfect square, so I need to rationalize. So I'm going to multiply by a fraction that simplifies to 1. But this time, my fraction that equals 1 will have square root of 3 in the fraction. So this is square root of 3 over square root of 3. Now again, don't reduce because we'll get back to our original problem. So we want to multiply the numerator. So that's square root of 2 times 3, which is square root of 6, over. Now multiply the two denominators. So that's the square root of 9. Again, don't simplify just yet because we want to go ahead. Don't reduce, that's what I mean. Don't reduce that just yet. We're going to go ahead and simplify. So square root of 6 is 2 times 3. Those are both prime numbers. We don't have any twin prime factors in the factors of 6. So it's going to stay underneath the radical. Square root of 9, though, is 3. So this is my simplified radical expression. Now again, this 6 and this 3 won't reduce each other because the 6 is underneath the radical. The 3 is no longer underneath the radical. Alright, another one. On this one, I'm going to first multiply 12 sevenths times 1 6. Now this is the part right here where it says reduce if needed. We're going to reduce. 6 goes into 6 once, 6 goes into 12 2 times. Now that's all that will reduce. So that is the square root of 2 times 1 in the numerator is 2, and the denominator 7 times 1 is 7. So now let's break that up a little bit. So square root of 2 over square root of 7. 7 is not a perfect square, so we're going to rationalize. We're going to multiply by the square root of 7 over the square root of 7. So in our numerator, we're multiplying the square root of 7 times square root of 2, which is the square root of 14. In the denominator, I'm multiplying the square root of 7 times square root of 7, which is the square root of 49. 14 doesn't have any twin prime factors, so it's still say square root of 14. The square root of 49 does. That's 7. Okay, and again, this 14 and this 7 will not reduce each other because the 14 is under the radical and the 7 is not. All right, let's look at a few more like that. So we're first going to simplify. I'm sorry, reduce. I'll get this right in a minute. So we have the square root of 10 over the square root of 70. I wanted to put that in the same fraction. So let's reduce the 10 and the 70. So 10 goes into 10 once, 10 goes into 70 7 times. So now I have 7 on the outside. On the inside I have 1/7. So let's put the 1 in its, the square root of 1 on top and the square root of 7 on bottom. Okay, so the square root of 1 is just 1. So that 7 right here is multiplied by the square root of 1. It's just 1. On the bottom, I have 7. So that's 7 times the square root of 7. All right, well, I've reduced it, but I still need to rationalize. So I'm going to now rewrite 7 over square root of 7, and I'm going to rationalize. So I gotta have a, I don't need to have a radical in the denominator. So in the numerator, I'm multiplying 7 times the square root of 7. Now, the 7 in blue is outside the radical. The 7 in red is inside. They don't multiply. It's just going to be 7 on the outside times square root of 7 on the inside. Over here, I'm multiplying 7 times 7 because they're both inside the radical. And now I'm going to simplify. Square root of 49 is 7. And now reduce again if needed. So this answer is just the square root of 7. Alright, so that one had a lot to it. First we reduced and got to here, and then we had to rationalize and reduce again. Alright, so over here we have 6 times the square root of 27 over 33. 27 and 33 are both inside the radical, so I need to reduce. They'll both divide by 9. Not 9. Sorry, I don't know why I said 9. 3. And we get 9 over 11. So this is 6 times the square root of 9 over the square root of 11. Well, 6 times the square root of 9 is 6 times 3. And 6 times 3 is 18. So I have 18 in the numerator and the square root of 11 in the denominator. Rationalize. And now multiply. 18 times the square root of 11 is 18 on the outside. Square root of 11. 11's on the inside of the radical. In the denominator, I am multiplying square root of 11 times square root of 11, which is square root of 121. Now simplify this, and we get 18 square root of 11 over 11. And again, this 11 and this 11 do not simplify each other, not reduce each other, because 111, the 11 on top, is inside the radical, and 11 on bottom is not. Okay, so let's look at another one to simplify first. Here we have 12 over 2 times square root of 125 over 5. So I'm going to reduce 12 and 2, that's 6. They both divide by 2. 5 and 25 both reduce by 5. So that is the square root of 25. So the square root of 25 is 5, and 6 times 5 is 30. Okay, so that is where we're rationalizing the denominator. Now, on the next video, we're going to look at a few more simplifying and some distributive properties.